Hello and welcome to a demonstration of advanced fields of applications for SPEETEC. We often get the requests if SPEETEC can also measure at standoff distances larger than 50 millimeters. In this video, we will demonstrate you that SPEETEC can measure at standoff distance of 100 millimeters or even more. We will demonstrate you the behavior of SPEETEC at larger standoff distance and how the SPEETEC diagnostic screen can be used in your application to get more confidence about the sensor behavior under these conditions. Before we start with the demonstration, I will give you a short introduction into the theory. SPEETEC sends laser light to the surface, which is reflected from the surface. SPEETEC receives the reflected light, and the strength of this received signal is called SNR. The SNR received by SPEETEC depends also on the distance between material and the sensor and the material itself. An accurate measurement of SPEETEC can be achieved if the SNR value is permanently larger 150 and the speed signal loss indicator is permanently below 0.2%. This chart here shows the typical SNR curve at different distances. As you can see, the highest SNR is achieved at nominal standoff distance, while the larger and shorter distances will result in a lower signal strength. Now I demonstrate this on different material. For the test, we use the following setup. SPEETEC sensor is mounted on the moving head of a linear axis. This way we ensure a slip-free and reproducible movement. The standoff distance of the sensor to the material can be adjusted. The linear axis will move 700 millimeters at a speed of 0.2 meters per second. SPEETEC is connected to the laptop with the programming cable and to the incremental counter. The measured speed and length value will be displayed on the incremental counter box. The sensor behavior can be monitored in the SPEETEC diagnostic surface. To use the diagnostic surface, you need to use a programmable device. For the first measurement, we use a smooth silk matte black surface. This is our reference material for the datasheet. Such material only gives little diffuse reflection from the surface, which is resulting in a low SNR. SPEETEC is mounted in nominal position of 50 millimeters. We now start the axis and the sensor starts moving. On the counter we can see the moving speed and the total length, which is 700 millimeters. On the diagnostic screen, we can see the SNR and the speed values. On the diagnostic surface, you can see that the SNR is about 200. The next material we test is cardboard, which is commonly used for corrugated paper or packaging. We start the measurement again. The counter shows the speed and the length, which is again 700 millimeters. On the SOPAS diagnostic screen, we see that the signal-to-noise ratio is above 6000, which is significantly higher. We increase the standoff distance to 60 millimeters and measure on the reference surface. This distance is outside the specification as it's above 50 plus minus 5 millimeters. Now we perform the measurement again. The cumulated length is just below 700. So the measurement was inaccurate. On the diagnostic screen, you can see that the SNR is just around 50, which is too low. Now we will challenge the SPEETEC sensor. On the cardboard, we will use a measuring distance of 100 millimeters. This is twice the distance as the nominal distance. Now we will start the measurement. The counter again shows the speed and the length of 700 millimeters. The SNR on the SOPAS screen shows you about 200, which is still sufficient. As you can see, the SNR is dependent on the material. We made more tests on other material, and here's a rough indication what can be achieved. The distances shown in this table is for reference only, and is only valid for the specific tested material and test setup. Now let me summarize what you have seen in this video. Different materials cause different reflections into the sensor, which result in a different SNR value. The higher the distance from the material, the lower gets the SNR value. Our datasheet values for the nominal distance of 50 plus minus 5 millimeters are based on a very challenging material and includes a safety factor for aging of the sensor. Most other materials with higher SNR at nominal distances can be measured also at larger standoff distances than specified in the datasheet. With the diagnostics function of the programmable SPEETEC, you can check yourself if the SNR is large enough to measure the material at a desired distance. Another influence on the SNR is the speed of the movement. If you want to know more about the influence of speed, please watch the upcoming videos. If you want to learn more about the diagnostics functions of SPEETEC, please check our diagnostics video. Thanks for watching this video and keep challenging SPEETEC.